Hi everyone, today we're working on transformations of sine and cosine functions, and we've already looked at sine and cosine functions. We've looked at amplitude and we've looked at changing the period. So we're going to just take it a step further in this lesson. But before we do that, I just wanted to point out some of the similarities. So first of all, with the sine and cosine curves, the curves are the same shape. Here we have our sine function, and here we have our cosine function. The curves are the same height with a maximum value of 1 and a minimum value of -1. If we were to translate the cosine curve by pi over 2, identical to the sine curve. So they're really the same shape, they're the same, they have the same amplitude, they have the same period, they both complete one cycle in 2 pi radians. Both functions are periodic, meaning they're going to repeat the same cycle of values. And the amplitude is the half the distance of the difference of the maximum and minimum. And the way, I've described it to you is the amplitude is the distance from the center. And I've just noted what the patterns are. The sine pattern is 0, max, 0, min, 0. And the cosine pattern was max, 0, min, 0, max. So for both the sine and cosine function, the value of a was at the front. B is the number of cycles. B is the number of cycles per 2 pi, right? And the period was 2 pi over b. And what we're adding today is a couple of things. First of all, the value of c. And notice we have a subtraction inside the parentheses here. C is our phase shift or our horizontal translation. If we have, for example, if we had x minus 2, that would mean we're moving the whole function right 2. If we had x plus 2, that would mean that we're moving the whole function left 2. D is our vertical translation. That's going up and down. So if D was 3, positive 3, that means the whole function would move up 3. That means our center would move to a value of 3 instead of a value of y equals 0. Or if we had d was equal to, say, -4, then we would have a center at the line y equals -4. A less than 0 is a reflection in the x-axis, and we've already looked at that. We haven't talked about this yet, though. B less than 0, so if we have a negative in front of the B, that's going to mean a reflection in the y-axis. So now we're going to try writing some equations based on the criteria for the transformation, and we're going to be transforming first y equals sine of x. So for letter A, we have an amplitude of 3, pi units down, 2 units left, and a reflection over the x-axis. All right, so we know that since we're reflecting over the x-axis, we're going to have a negative in front. That takes care of this. The amplitude is 3. All right, now the rest of it has to do with moving it down and left. So we're going to write the sine, and something's going to happen inside the parentheses. Since this function is moving 2 units left, we're going to do plus 2 inside the parentheses. That takes care of this. And pi units down, we're going to have minus pi on the end. All right, that's letter A. For letter B, the amplitude's 5, 3 units up, pi over 2 units right, and a reflection over the y-axis this time. So we do not have a negative in the front because the reflection over the y-axis will be in front of the b value this time. So we have a 5, we have sine. Reflection over the y-axis means we're going to have a negative in front of our b value. Now, if you want, you could put a 1 there. You don't have to. Might make you feel better to note that b is 1. I'm not going to write it because we don't typically write it. We know that we're going pi over 2 units right. So we're going to do minus pi over 2 inside the parentheses. Takes care of this. And then 3 units up plus 3. For number 2, we're going to write the equation for each transformation of y equals the cosine of x. Amplitude 6, 4 units down, 5 units left, and the reflection over the y-axis. All right, a reflection over the y-axis is going to affect B, not A. So we know that the value, we just have the value of 6 here. We don't have a negative in front. We're doing this for cosine. We have a reflection over the y-axis, so we have a negative here. Maybe for fun this time I'll put a 1. It might make you feel better. That means that B value is negative. We know that we're going 5 units left. So we're going to do x plus 5 and 4 units down. All right, last one, letter B, amplitude of a half, 7 units up, pi over 4 right, and a reflection over the x-axis. So we have y equals a negative 1/2. It's cosine. We're going right, so we're going to do minus inside our parentheses, pi over 4, and then 7 units up. All right, hopefully you're starting to feel pretty good about that. We're going to look at a graph now, write down the amplitude and find the period, and then write the equation of the function. So the amplitude is the distance from the center. So from here to here, it's 0.5. Right here, we're landing at 0.5. So the amplitude's easy. The amplitude is equal to 0.5. I'll just make a note that that's the distance from the center. Right, we also need to find the period. So we need to know how many cycles occur from 0 to 2 pi. So, because B is the number of cycles that occur from 0 to 2 pi. So here's 1 cycle, here's 2 cycles, here's 3 cycles. So just by looking at this graph, we know that the value of B, make a note, is 3. So then the period is 2 pi over B. So our period is 2 pi over 3. All right, so let's see where we're at. Write down the amplitude. It's important to remember that whenever IB says write down, you should be able to look at the equation or the graph and know the answer without doing any calculations. So like we did it when we looked at the graph, we could tell the distance from the center was 0.5. So we simply wrote down the value of A of 0.5. We found the period, and now we're going to write the equation of the function. So the equation is in this form. C is equal to 0 because we have no movement left or right. We have no phase shift. And D is where our center happens. So our center on this graph is happening right at 0. It's happening on the line y equals 0. So D is equal to 0. And now we can fill in all the values and write the equation. All right, number 4, we have a function. Write down the amplitude of f. We just look at this function and we know that the value of A is 6. Right? The value at the front of the function is the amplitude. Now we're going to find the period. The period is equal to 2 pi over B because this is a sine curve. And we know that B is pi over 2. Whenever you divide by a fraction, to simplify, you're going to multiply by the reciprocal of the denominator. The pi's cancel, and we end up with 4. So A is 6, and B is equal to 4. It says sketch the graph. We're looking to sketch the graph between 0 and 2 pi. Right, so we want to identify all the important values. We want to know what's the amplitude, what's the period, is there a phase shift, and is there a vertical translation. So right off the bat, we can see that the value of A is equal to 3, our amplitude is equal to 3, our period is going to be 2 pi over B, so the period is 2 pi over 2. So our period ends at pi, very important to know that. We don't have anything inside the parentheses moving this function either left or right, so we know that we have no phase shift. We do have a plus 1 on the outside. That means we have a vertical translation up 1. And that means that our center occurs at the line y equals 1. We have a center at 1. The vertical translation tells us the center. I can't say that enough. That's a really important concept. Now, one more thing to note, we do have the cosine graph. We don't have a negative out front. So the pattern that we're expecting for this is max 0, min 0, max. And the first thing I'm going to do is I'm going to sketch in where my center falls. We said our center is at 1. So I just want to do a dashed line to represent my center. All right, and my amplitude is 3, so I'm going to go distance from the center up 3, and then from the center I'm going to go down 3, and I'm going to mark those so that I have, some guidelines for the maximum and the minimum of my graph. Now I know that my period ends at pi and my pattern is max 0, min 0, max. So let me just do my 5-point pattern. I have 1, 2, 3, 4, 5, ending at pi. I'm sketching this to 2 pi, so I need to do another cycle. 1, 2, 3, 4, 5. So here's 2 pi. And now I can plot my points. Max 0, min 0, max. Max 0, min 0, max. And sketch your curve. All right, that's number 1. Let's try another one. This time we're going to be looking at sketching the graph of the sine curve with some transformations. We're going to write down the value of A. A is equal to 2. The distance from the center will be 2. Our period is going to be 2 pi over B. In this case, B is right here. B is 1. So we have 2 pi over 1, which means our period is just 2 pi, which is important because, we want to sketch this graph between 0 and 2 pi. We do have a phase shift. We are moving this whole function left pi. And lastly, we have minus 1, which means we have a vertical translation down 1. And the vertical translation tells us we have a center at negative 1. So we've taken care of this, and we've taken care of this. All right, so the phase shift left pi is a little tricky. So we know that to start our cycle, we're going to be over here. We're going to be at negative pi because we moved everything from 0 over left pi. And then we have a 5-point pattern from there. 1, 2, 3, 4, 5. And that's going to land at pi. So we're equal distance on the left and the right from the y-axis. So we go from negative pi to pi for one cycle. And we want to sketch this graph to 2 pi, so we're going to keep going. 1, 2, 3, 4, 5. That's one more cycle. And pi plus 2 pi, that gives me 3 pi. Now this is a little tricky because we only want to go to 2 pi. So halfway between pi and 3 pi is 2 pi. And I want to mark that because that's where I'm going to stop sketching my graph. All right. Now, the next thing I want to do is I want to make lines, put dashed lines at my center, my maximum, and my minimum. My whole graph is going down 1, so I have a center at negative 1. My amplitude is 2, so I'm going up 2, 1, 2. So this is the maximum of my graph. And I'm going down 2, so 1, 2. So that's the minimum of my graph. Let's note the pattern. All right, we don't have a negative out front. This is a sine curve. So the y equals the sine of x pattern is 0 max, 0 min, 0. All right, we're all ready to go. We're going to plot our pattern now. So I have 0, max, 0, min, 0, 0, max, 0, min, 0. I'm going to use dashed lines before 0, and I'm going to use dashed lines after 2 pi. And if you want, you can even maybe highlight it to make it really stand out, because we're only being asked to sketch out from 0 to 2 pi. Just going to make that a little bolder. All right, and that's it for number 2. So just keep in mind that this takes a lot of practice. You're going to have to take your time and note your amplitude, your period, any kind of shifts you have, what your pattern is. And then if you take all these steps, you shouldn't have any problem at all. Have a great day. Thanks for watching.